let's go over one more example of finding the area of regular polygon. In this case, we are given a regular pentagon with the side being 7 meters. Because this is a regular pentagon, we know all sides are the same. So in the formula for the area of regular polygon, we already know that the perimeter is going to be 35 by adding all sides together. And keep the apothem, keep the 1/2. Now, how do we find the apothem? Well, remember that the apothem is the distance between the center of the circle in which this pentagon is inscribed. So let me draw that. So that's a circle. Sorry for my bad drawing. So the apothem in the red is the distance between the center of the circle to any one of the sides of this regular pentagon, and it is intersecting the side perpendicularly, so there's a right angle right there. Now, to find the apothem, it is worthy to notice that not only the pentagon is equilateral, it is also equiangular, so all of these angles have the same degrees, like this. And then we can go ahead and cut this regular pentagon into different triangle. So something like this. Like that. Now, in this regular pentagon, we have 5 central angles versus the hexagon where we have 6 central angles. Because if we start at one spot and we go all the way around, that's going to give us a total of 360 degrees. And because this pentagon is a regular polygon, we know that if we take the total degrees, which is 360, and divided by the amount of central angles that we have, which is 1, 2, 3, 4, 5, we know 360 divided by 5 is going to give us 72 degrees. So this is 72, this is 72, this is 72, this is 72, and same thing for this one. Now, you can go ahead and draw the apothem in this triangle, this one, or this one, but we already drew one right here. And we know that all of these triangles are going to be the same anyway because this is a regular pentagon, and we cut the regular pentagon into all same triangles. We're just going to go ahead and consider the bottom one. Draw a picture. The picture of, I should say the entire triangle first. Like that. So this is 7, and this is the apothem, and this is 72 degrees. Well, if this angle here is 72 degrees, and it got bisected by the apothem right here, we know this half is going to be 36, this half is going to be 36, okay? So we got 90 plus 36 equal to 126. 180 minus 126 is going to give us 54, right? If this is 54, then using the same triangle angle sum theorem that we used to find this angle, we know that this angle is also 54 degrees. So how do we find the apothem? Now, to find the apothem here, it is worth noticing that we should pick one of the 2 halves of this triangle. So I'm going to go ahead and pick the left half. So the left half is going to look something like this. Like that. This is 90. This is 54. And this is 36. Now, remember that this entire base here is 7. But because we only pick 1/2 of this entire triangle, we technically only pick half of the entire base. So the entire base is here. This is only half of it. So this size right here is actually 7/2. We want to go ahead and use the law of sine. So by the law of sine, we get to set up a proportion, and the proportion is technically 2 fractions equal each other. What are those 2 fractions? Well, one fraction is going to consist of the apothem, which is, well, I'm calling it letter A. The apothem A divided by the sine function in terms of the angle that is opposite to the apothem, which is 54 degrees. And we set it equal to the same ratio, but it's going to have different components. Well, I'm going to go ahead and set it equals to 7/2 divided by sine of the angle that is opposite to 7/2, which is 36. So we got 7/2 divided by sine of 36 degrees, like that. And I can go ahead and solve for the apothem right away. So I can do that by multiplying both sides by sine of 54, so that a can be by itself. So let me go ahead and write the math down here. By multiplying both sides by sine of 54 to get the apothem lowercase a by itself, I got a equal to 7/2 multiply sine of 54 degrees divided by sine of 36 degrees. And just go ahead and put it in the calculator. We are going to get, I will say, 4.82 meters. So the apothem is approximately 4.82 centimeters. So all we have to do is that we take the value of the apothem, 4.82 meters here, and we plug it into the equation. So approximately equal to 1/2 times 4.82 times 35. So putting this entire product in the calculator, we are going to have approximately, the area is approximately equal to 84.35 meters square. And this is the answer.